This video will cover the tricky trinomial factoring method. We're going to use something called guess and check because that's a good method for helping you to understand this and one that will, frankly, always work. It must be a trinomial, meaning 3 terms, and must have a number in front of the x squared. So the difference between last video and this video is that in the AM method, we did not have this term here. The coefficient was just a 1, which in that case was invisible. Here we have a number in front of the x squared, and there's no GCF. We should also take note of that. No GCF. So if there was a GCF, you'd have factored it out at this point. There might still be a number left over after that GCF is gone, but there's no common factor right now. So what we have to do is make our 2 parentheses. And in order to make this term to be 2x squared, normally we're just like, oh yeah, x and x, because that makes x squared, but this has to make 2x squared. And so to make that, I have to have a 2 times a 1. That's the only combination to get 2x squared. 2 times 1 is 2. Okay, so you have to deal with that coefficient first. Then we have to think about how to add and multiply for the second 2 terms. So this is the trial and error part. When you distribute, does the problem multiply to the original question? Repeat until you get the original trinomial. So you can think of numbers that multiply to 18, like 1 and 18, 2 and 9, 3 and 6, and I think that's it. But then you have to be careful about what you plug into where, because we want to add this term here and this term here to 9. So let me pick another color here. And we're going to start doing our little guess and check thing. So you probably want to use pencil when you are doing this, because you're going to be guessing and checking, meaning that you are going to be writing and erasing. Okay? So if I start with, say, the 1 and the 18, if I put 1 here and 18 here, this gives me a 1 times 1, which is 1x, and a 2 times 18, which is a 32x. I don't think that there's any way for me to get this 9x by adding 1x and 32x. So I'm going to have to erase that. Very slowly, clearly. Okay, so 1 and 18 doesn't work in that spot, but what if I change it? 18 here and 1 here. So now this is 18x, and this is 2x. And again, all I did was say 18 times 1x, 2x times 1. So now I'm thinking if I have 18x plus 2x, or 18x minus 2x, or whatever the combination, negative 18x plus 2x, is there any chance of me getting positive 9x? And the answer should be no. Okay, so I'm going to erase again very slowly. Boop, 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 boop. I'm sorry, I'm just using the undo button because I don't want to mess up everything. So 1 and 18 didn't work. Next I'm going to try 2 and 9. So I'm going to place 2 here and try 9 here. We'll see. Who knows? So I've got 2 times 1x is 2x. Then 2x times 9 is 18x. I don't think that's going to work. The same combination that we had the last time. But maybe we can switch their spots. Okay, so try the 9 here and the 2 here. 9 times 1x is 9x. 2 times 2x is 4x. I still want to try to get 9x, and that doesn't seem like it's going to work between adding these values. Okay, so let's try 3 and 6. Try 3 here, 6 here. 3 times 1x is 3x. 2x times 6 is 12x. Ooh, 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 ooh. if I add those, there is a way to get a 9x since I have to multiply to a negative anyways. Now I have to decide which one needs to be negative. Do I want 3x minus 12x? That would give me a negative 9x, but I want a positive 9x. So I want a 12x minus 3x. So to get a minus 3x, I need to stick a negative in front of the 3 so that when they multiply, they are negative. To get a positive 12x, I need a positive in front of the 6. So our final answer here, what we just decided, is that if I took 2x minus 3 and x plus 6 and factored it out, distributed it out, we would have 2x squared plus 12x minus 3x minus 18. And when I combine like terms, I have 2x squared plus 9x minus 18, which is the original problem. So this here, ladies and gentlemen, is our final answer. Now, I know that was a long and grueling process, but guess what? We could have probably skipped trying the first choice anyways, the 1 and the 18, because it doesn't seem to make sense if I'm multiplying one of those values by 2, by that 2x, there's probably no way I'm going to get the 9. Okay, because 1 times 2 is not enough to take away from 18, and 2 times 18 is obviously way too big. So you can kind of eliminate based on just the numbers that you see and some common sense, but other times it is a lengthy process. Sorry. So we're going to try it again here with this quadratic. 6x squared minus 17x plus 5 equals 0. And in this case, we are going to solve. So the last one, it did not have equal 0, so we didn't have to solve. But this time we do. This problem requires us to solve since we need to set each vector equal to 0. All right, so first we're going to set up our parentheses because I don't see a GCF. There's nothing in common between 6x squared, 17x, and 5. But I need to find factors of 6x squared. Now think of your numbers that multiply to 6. You could have 1 and 6, or you could have 2 and 3. So this makes our work a little bit more challenging. This will be fun, right? So much fun. You guys love math. Okay, so let's try, say 6x and 1x first. Okay, so we're going to try this combination first. But remember that we need to add and multiply to negative 17x and 5. Well, the 5 makes your life really easy because there's only 2 factors. 1 and 5. So I'm going to try the 1 here and the 5 here, and I'm gonna make my little smiley faces because I need those 2 values to add to negative 17x. So I have when I multiply 1x here, and when I multiply I have 30x here. If I attempt to add these two, they do not give me 17, nowhere near it, right? So I'm gonna do a little bit of erasing or undoing in this case. I'm going to put my little smileys back there so I don't have to keep doing them over again. And this time I'm going to try 5 here and 1 here. So when I multiply, I get 5x and 6x. Well, if I add those, I could potentially get 11x, or I could get 1x if one of them's negative. If both of them are negative, it could be negative 11x, but that's still not 17x. So, listen, we just tried 1 and 6 with the 1 and 5 combination, so we have to start over. This didn't work, so I'm going to start over. I have now, we're going to try 2x with 3x. We've got our little smileys going, and we're going to try the 1 and 5 combination again, because again, those are the only factors that multiply to 5. So let's try 1 here and 5 here. When I multiply the small smiley, I get 3x. When I multiply the big smiley, I get 10x. I can't make 17 out of that, though. Remember, we're trying to add to make 17 when I take these 2 terms. So I'm going to erase and swap my 1 and 5. So here I have 15x when I multiply the small smiley, and 2x when I multiply the big smiley. 15 and 2, holy moly, we get 17. Isn't that fabulous? But remember, it needs to be a negative 17. So in order to make a negative, that means I must have a negative 15 and a negative 2. So I need both of these terms to be negative negative. So we've done a great job so far with factoring, but don't forget we need to solve. If you want to test out your factoring, don't forget you could double distribute in order to check your work. But you're going to assume that because Miss Griffin is a math genius, your work on your paper right now is correct. But if you were doing this and you're like not quite at the math genius status yet, then double check your work. Okay? So now I have to teach art because it's set equal to 0. So I'm going to set each factor equal to 0. And I'm going to solve it just like I would for any other equation with x. I would now have 2x equals 5. To get this x by itself, I have to divide by 2. So first root is x equals 5 over 2. Then for the second one, add 1. 3x equals 1. Divide by 3 to get x by itself. And now I have x equals 1/3. So final answer for this, we have 1/3, comma, 5/2. Or you could box in your x equals. Okay, so I know that that's a horrible process, but like I said, sometimes you can figure it out just by logic. But I took you through the whole lengthy process in case you are struggling with that logic. Excuse me. If you have questions, of course, ask us, email us, let us know so that we can help you.